In this video, I'm going to show you homogeneity of differential equation. When do we say a differential equation is homogeneous? So homogeneity of differential equation is determined by proving that f of tx ty is equal to f of xy. All that this means is if you bring in a constant t to multiply by your variable, when you put this into the function, you should get the function back. Then we say that your function is homogeneous. I have examples here for us to use to understand homogeneity of differential equation. Let's see the first example. In the first example, I have y prime is equal to y plus x over x. How do we show that this equation is homogeneous? So to show this is the same as our f of xy. So we are to, this is a function. So this is what we are interested in. So this is what you are going to do. You have y multiplying t plus x multiplying t all over what? X multiplying t. And it is expected that we get this function back again. So to get this function back again, it is simply simplifying this. You know that I can still factorize t out. So t out x plus y all over tx. My t will cancel and I'll get my x plus y on x, which is the same as y plus x on x from this side. So after the t was multiplied with our x and y, our equation remained the same. Hence, this equation is homogeneous. Now, let's try the second example on homogeneous equations. So the second example is y prime is equal to y squared over x. So in this example, I'm going to show you how to prove that it is homogeneous. You need to multiply this by ty all squared all over t multiplying x. From here, you are going to get t squared y squared over tx. This t will cancel this t squared and you are going to get t multiplying y squared over x. And you can see that this is not equal to what this. We started with y squared on x and now you have ty squared on x. Hence, this equation is not homogeneous. So the next example, that is example 3. Let's see. We have this equation y prime is equal to 2x y e to the power x over y all over x squared plus y squared sine x over y. How do we prove that this equation here is homogeneous? As we did, wherever you see x, you multiply it by t, so you are going to get 2xt multiplying yt e to the power xt over yt all over xt all squared plus yt all squared sine xt over what? Yt. So we move on to simplifying this expression here. So at this point, you realize that this place you get 2xt squared e to the power, this t and t will go away, so x and y over the same thing here. I'll get t squared x squared plus y squared. I'll factorize this t squared and t squared out, then this t will also cancel out and I'll get sine of x over y. At this point, this t squared can cancel this t squared and I'll get my 2x e to the power x over y all over x squared plus y squared sine x on y, and hence my equation is homogeneous. The final equation which we are going to talk about is y prime is equal to x squared plus y over x cubed. Likewise, we get xt all squared plus yt, all this over xt all cubed. I'm going to get t squared x squared plus yt all over s cubed t cubed. Now at this point, I can only factorize t out here and I'll get tx squared plus what y over t cubed x. And now the t will cancel the down one and I'll get ts squared plus y over t squared x. This is not equal to what we started, hence this is not homogeneous. Thank you for joining me in this class. Please subscribe, like and share.